It's a really good aid at spotting things really fast. Like a fully autonomous AI-driven system, we would have got turnarounds. Pilot does that himself, but if we could take that weight off his shoulders, it helps a lot.
Hello, I'm Ben Sampson, editor of Aerospace Testing International, the world's leading magazine dedicated to the application of testing, evaluation, and inspection in the aerospace industry. I'd like to welcome you to this episode of the Testing Talk podcast from ATI. The interview today is with Sylvain Alarie, VP of Engineering from AI and autonomy company Daedalean. If you don't know Daedalean, they are a really interesting company from Switzerland that has been developing autonomous systems for aircraft for several years now, with the aim of one day developing a fully autonomous piloting system. Before then, the company plans to release a number of autonomous safety systems for aviation. The first one is expected to reach the market at the end of this year. I spoke to Sylvain at the Paris Air Show about the company's technology, how it works and its capabilities, and also about how it's ramping up testing and development. What comes across is that companies such as Daedalean really are at the forefront of what's possible currently, so much so that regulators are having to try really hard to keep up with the innovation. So wherever you are and whatever you're doing, get comfortable and listen to my interview with Sylvain. We were just talking about Illumina Vista.
Yes.
And that is that the main products that you're selling now, or?
No, it's one of our products. And again, we're just starting up now on real product delivery. But Illumina Vista is a traffic system that we're certifying on a helicopter, and that will be the first certification of AI on an aircraft for a critical function. It's DLC, but it's still a critical. So basically, what we do is we provide traffic advisory to the pilot.
Okay, so
display.
like a warning of a aircraft when it gets too close.
Yeah.
Basically, like there's an equivalent on a runway. Is it like a TCAS?
Yeah. It's not that complex.
Yeah.
It's really a step into it. And of course, since AI is all new, and so we couldn't throw too much at them, like a fully autonomous AI-driven system, we would have got turnarounds. So it's really the first use case. So basically, the benefit of the system is the pilot, they have these, how they scan the, and while they're flying the helicopter, it's a fairly, especially at low altitude, it's a fairly stressful, busy time. So what we can do is we can scan the sky way faster than they can, and we can identify traffic, tell them where it is, and give them a class of what size traffic that is, which gives them an idea of what it is. And so it just helps them see it on the street, and they can look out the window and visually confirm it's there. I mean, they're still responsible, but it's a really good aid at spotting things really fast.
Just a couple of questions on that. You're flight testing now at the moment on a helicopter, did you say? Tell me what that entails. So you'll fly the helicopter up and arrange for another aircraft to come close?
We've done that to develop the system, but for certification, it's going to be more simulation and test based, and then just some flight testing to confirm the human factors and everything. But we do a lot of testing to gather data because it's an AI-driven system, it's cameras. So we need a lot of data to be able to then train the model. And what you train the model with and verify the model with have to be two separate databases that are independent, which is a demonstration you have to make to the authorities. And so it requires a lot of data. What we can also do on the training side is use simulation. So we have real images and we can superimpose real pictures of aircraft in there, create scenarios, different lighting conditions. But in the end, we need to use real data. So we're constantly flying and testing.
So your system is a camera-based system. And that unit, I see the other features there that you've got that are happening. It all comes from the same unit of hardware, does it? You're fitting this camera system on?
Yep.
Can you describe that to me?
It's just basically a pod that mounts on a standard aircraft mount. That's just SPC, so we don't have to deal with the certification of that thing. And these things, they have standard interfaces. So people who make cameras or searchlights or whatever, they make to this. So we designed our camera pod, to mate to that. It's got a forward camera and a downward looking camera.
Okay.
So the forward we use for traffic. Yeah, and that's what we're certifying. But the other systems we're testing with some partners, we do visual positioning. So that's the downward facing camera. The landing site clearance.
And everything's processed on board the aircraft?
Everything's processed on board the aircraft in
Okay.
our computer. It's completely self-sustained.
Okay. So I know you're probably taking me through this step by step. So you got what's that system called? The hardware. Does that go on any planes, retrofit?
It could.
Yeah.
It could if they have that mount. So we have it now on some Airbus helicopters for testing.
Yeah.
We're certifying it on the Robinson. It's a fairly standard interface, but otherwise we just design the installation.
You would,
whatever people want.
Okay.
Some people already have cameras. Business jets have cameras. So they come to us and say, hey, can you run with our camera?
Oh.
Well, give us a sample and we'll test and see what the gap is and
Yeah.
how much effort it is to pixel.
Okay.
But so we're fairly agnostic.
So off the back of that hardware, you're developing the flight safety functionalities, really, aren't they? Features.
Yep.
And you're starting with the proximity. I guess what do you call it? Aircraft proximity sensor or something?
The traffic detection.
Traffic detection system. Yeah. Okay. So what else is coming?
So that's traffic. We're working on obstacle detection. So wire detection is really big to helicopters.
Electricity
wise. Yeah, they run into or the gondola wires or especially in Switzerland, they run into them all the time.
Okay. Yeah.
So it's a big problem for them. And the systems that have been developed are fairly expensive and don't cover the whole gamut. So we're working on that now. We're detecting towers and radio towers and things like that. We're also looking at landing sites. So when you have a failure condition in a helicopter, it's a fairly stressful time. You have to come down. We can tell him where a safe landing spot is because we can visually detect. Pilot does that himself, but if we could take that weight off his shoulders, it helps a lot. And we can also determine if the landing site is clear or if it's been compromised by somebody who's driving their car there.
So the idea is you're going to develop those pictures and then roll them out.
We'll roll them out, yeah.
Yeah.
It's so we have a roadmap. It's a little tricky because we have customers want different things. So they tend to want to interfere with our roadmap and you do this first and that's how we're juggling it. But yeah, that's our idea is to just successively roll out creatures.
So where are you going to be certified to use these systems? I mean, they have to obviously pass. I mean, the regulations exist already for them or?
Yeah. So this is why it's so important. This first thing we're doing, it's going to be the first time machine learning has been done.
Yeah.
And so EASA, we work with EASA. We co-authored a lot of documents for them, which are basically similar to the RTCA DO documents by software and hardware.
Yeah.
But this is for machine learning.
Okay.
So it's not a DO document yet. It's EASA guidance. Yeah. I can see that in 5 years or something, if this really takes off, somebody's going to make it. RTCA is going to make a document out of it. So there's all the guidelines in there that look a lot like 178 and 254, but they're for learning assurance. A lot of the same steps are there. And with this learning assurance, then that certifies basically the machine learning part, the AI part.
Okay.
And then that is implemented in hardware and software.
Yeah.
So then we take that, we code it in C++. And so that goes through the normal software process. That is hosted on processors and accelerators that follow the hardware process. So this is just to address the model part. It's a little bit like when they started doing model-based software development.
Do you have to show to EASA that you're meeting those guidelines?
Yes.
Yes.
So how we develop the model, how we train the model, how we verify the model on the backside. So that is one process. So we know the model is good. Yeah. But the model is on our servers and all that. Then we need to take that model and implement it in our hardware and software. So then we have our aerospace people who then run that through the normal development process. So these three legs are what EASA are looking for. And we work with the FAA too. We're doing both at the same time. So we have an audit next week. We have both FAA and EASA in the room at the same time.
Okay.
And it's pretty rare.
And you're going to have your first system certified by the end of this year, and that is the traffic detection system. Yes. And can you give me a little bit more detail on what the next steps for the remainder of the year will be? June, so there's like 6 months left. I mean, you demonstrate it on an aircraft to EASA as well?
So right now we are going through, so there's 4 audits.
Yeah.
Part of the process. We're going through the 4th audit is basically everything's good. All right. We're in. So the 3rd audit is basically the testing verification audit.
Okay.
So the first one is, do you have all your planning in place? What are you going to do? What is your plan?
Yeah.
To certify this? And they look at it and they say, that makes sense. That holds water. Go. The second audit is basically developing all the requirements and the design. They look at that, see if you followed your plan, the design looks good.
Yeah.
Now we have to show theoretically about 75% of the verification
Yeah. Okay.
of the software, the hardware, and the model,
All right.
which is the new part.
Yeah.
And so that's what we're doing next week. Once that is done, that goes well, then we finish everything up. We finish the remaining tests, whatever bugs we have, we fix and all that. And then we do the final head nodding. Everything's good.
Yeah.
And so we think, we're end of June. We think 6 months to get to the last step is
So
good.
the kind of natural question is, do you have a first customer? Who is it?
So we do have a customer. We can't disclose right now, but it's
right. Yeah.
it's a military customer. It's a
okay.
defense application.
Yeah.
So that's one of the reasons why we can't really disclose it.
Yeah.
But on the commercial side, not yet. We have a lot of really interested people that because this is so new,
Yeah.
especially they don't have a problem with the hardware, the software side, but the machine learning side, they're all like, when you guys are done, come see us. We really want it, but we're still a little worried that, we start the process on our side and then you guys get roadblocked by EASA and now, so they're still a little sketchy. So we have really, really good feedback. Everybody wants the various, not just traffic, the wires, all the other stuff.
Yeah.
Very good feedback both on airplanes and helicopters, but people are a little bit waiting. So this is why we're full push on it, because we see this as the state.
And a massive milestone for the
And then it's just going to open up.
And once you've done it once with traffic avoidance, it'll just get more efficient.
And all the standard work is done.
Yeah.
So there's a lot of reuse, and so our costs go down
Yeah.
a lot. And even on the authorities, because this is so new, we had to walk through a lot of things with them. They didn't know what they wanted to do. So it was really collaborative. That's why I said we co-authored a lot of the guidance material with them. Second time around, they know, right? And they're like, okay, we did that. We don't want to do that. It's going to be a lot more streamlined.
So just a couple of questions, couple more questions. First was on human factors. Yeah. I mean, how much work are you doing on that? I mean, what will there be like an alarm sounding up? I mean, it's a really, really tough subject, right?
Yeah, the human factors part is really big. So again, for this first system, because it's an advisory to the pilots, we kept it fairly basic. So we basically tell him what the aircraft is, which way it's going, and we don't want to make it too complicated, because then you get into all the human factors and distractions, indications, alarms, and all that. Already, we had to do a lot of human factors work to demonstrate the safety benefit of the system reply. So are we just distracting the pilot or actually helping him?
Yeah.
So we have a full cabin, a full Robinson 44 cabin with a wraparound screen and our system installed in it.
Yeah.
And it's black curtained out. We've brought in a lot of pilots that we've contracted from outside that don't know our system too much.
Mm-hmm.
We give them a very basic training on the system, and then we have them fly through various scenarios, and we increase the difficulty factor as we go, and then they give us comments and all that, and so they rate the system. So we have human factor engineers, so they do this per whatever the rules are for human factor people, and so we do that, and then EASA has to also do that same assessment.
But the benefit, obviously, in safety terms, is
we have superhuman performance in the sense that we don't get tired. We scan the sky at 6 times a second. Noise doesn't bother us.
Yeah.
Somebody in the back seat or anything.
Right.
So we are constantly alert.
Yeah.
And so there is obviously a benefit there. The thing is then giving that back to the pilots, the human factors that you rightly bring up, that's where you have to be a little bit more careful and not overwhelming. So right now what we do is we have our cameras obviously, but there's also other sensors on the aircraft. Sure. Notably for traffic. So we can take that signal and take ours and match them together and produce a single output.
Yeah.
So that the information they get comes from multiple sources. So we have some fusion algorithms that we do. Same for positioning. We can fuse GPS and the visual together, so you get one position.
So you could even have incoming aircraft and positional data for stuff that's beyond visual line of sight at the moment.
Yes.
Yeah.
That comes in through the instruments and satellite base.
Yeah.
We take that and we mix it with our visual, so we know it's coming, right? It's and then when we confirm it visually, they actually get a little icon that is not only radio based but visually confirmed, and that he sees it.
So the term here would be situational awareness, right?
Absolutely.
Yeah. No wonder the military are interested.
And then we don't develop avionics. We're not an avionics. I mean, we're in the field of avionics. We're not a Honeywell, a Thales, a Collins. So what we do is we interface with their displays, right? That's where you want.
Yeah.
And we work with their human factors people. So we have done this with Moog Genesis. So not only did we install our system on their flight test aircraft to do some testing,
Yeah.
we also went further and integrated it within their cockpit display. So they have a specific page that they can turn up,
Yeah.
and they have our system running there, and they can monitor it.
It's interesting to see where you're placed alongside those guys. So, a couple more things. How is this similar to what you get in a car now? Can you draw parallels to?
Oh, it's very similar.
Yeah.
It's better. If you've driven around in a Tesla, you'll see that, like, even it shows you stuff on the screen, right? And you see like bicycles or something, and they're constantly flashing. And that's because it's dropping it and picking it up, man. And we don't drop. We have very high requirements for detection and also what we call repulse, so not dropping it through the whole track that is interesting to the systems. It's coming across their screen. We don't lose it. Well, I mean, there's nothing's perfect in this world, but we have very high criteria for that, much more than they have in automotive. But otherwise, yeah, I'll digress a little bit. So our positioning system for the landing site and the hovering capability shows them what's under the aircraft. Like I said, we can see the landing site and if it's compromised. And so the helicopter guys are like, yeah, you know my car? I see my car from the top view. You know what's around it. Could you do that? So we had our guy hack something up. And yes, we can display their helicopter. We can put a circle around the diameter of the rotor. And of course, you have the image. So if there's a tree and you see your rotor diameter, you can, see where the danger is.
Yeah.
So that's kind of like the parking feature on your test.
Yeah.
So yeah, a lot of stuff is very similar. I think it's going that way. Yeah.
Is the goal still full autonomy?
Ultimately.
Yeah.
I thought so. Yeah. So it's pulling from all directions, the drones, the eVTOLs. Yeah. They need to go beyond visual line of sight, fly with other aircraft. So they need these enhanced features to be certified and to get their allowance to fly. The eVTOLs, eventually, they need to ditch the pilot. I mean, that's a revenue seek right there that they don't want to. So most of their roadmaps are autonomy. And then on the existing commercial side, is reduced pilot operation is a long-term thing. They have a lot of hurdles they need to solve.
Yeah.
But these are things, if they want to do that, we can help them. People talk about having one pilot and the pilots are complaining and all that. But before you even go there, you have FedEx flying from Memphis to Shanghai with 3 pilots on board. You could at least get rid of one and have 2 and have an AI system be the 3rd pilot. I think AI offers a lot of things, and we're developing stuff, but people come with ideas as well, that they're like, hey, could AI do this? And
Yeah.
I go, thought about that. Yeah.
But
I think we could.
But the safety stuff, I mean, it's going to bring money in, right? And it's also, so there's revenue there, and it's also going to build trust in the systems, right?
Yes.
That's the key thing.
And that's why we need to deploy a system that's not too ambitious right now. Get it out there, get the authorities comfortable with it, and get people flying it and saying, oh, yeah, this is good. I mean, I'm old enough that when I was in the original fly-by-wire aircraft, and it was the same thing. They all had mechanical backhones. And, even the side stick, the Boeing guys didn't want to have anything to do with side sticks.
Yeah.
They had big columns. And nowadays, nobody builds an aircraft that does not completely fly-by-wire without any mechanical backup. It's just the way you do it now.
Yeah. Okay.
Things have to progress, and so we're very eager to do a lot because we see a lot of potential in our system.
Yeah, I'm impressed, and I feel like the company's approaching a real breakthrough moment this year with this product.
Oh, this year is huge for us.
I hope you enjoyed my conversation with Sylvain Alarie, VP of Engineering at Daedalean. Join us again soon for another episode of the Testing Talk podcast from ACI. In the meantime, stay in touch with us at aerospace-testing-international.com, on LinkedIn, and via this podcast. That's it from me. Until next time.